F4.
Hello, everybody, and welcome, welcome, welcome. Thank you so much for joining us today. Today is the day when we are showcasing our student code jam. We're doing the Jingle Bell Jam. So, my name is Tiffany Hall. I'm an alumni of TripleTen Software Engineering Program. I am currently a full stack engineer at Scholastic Inc., which is the world's largest publisher of children's books and a digital education powerhouse as well. I also own Rylex Custom Works, and tonight I am your host for the Jingle Bell Jam. So thank you so much for joining. If you're not familiar with a Jingle Bell Jam, let me go ahead and just kind of give you the review, okay? So at TripleTen, the code jams that we do are a friendly competition that occurs for our students during their normal coursework. So in this code jam, we have put together teams of our software engineers and our data scientist students. These are super short competitions. In this one, we gave an extra day because there's data science involved, and it was 5 days. Normally, they're shorter than that, if you can believe it. So we bring these students together, and they get together when it works for them, and they jam out a bunch of code to meet the prompt. There are prizes, but most likely the students are here to compete for the thing that we all want, which is pride and coffee. And at this time of the year, I'm not going to lie, peppermint candy cane. So, whether they are learning new code, when they are learning new code each day, nothing feels better than to be able to display what you are learning to the world. So that is what we will be doing here today. Our code jams consist of 3 parts. There's the coding part, the modeling part, and the final presentation. This past Monday, our participants were divided into teams of 3. That was 2 developers and 1 data science student, and they were challenged to create an optimal route for present and gift delivery during the holiday season. Like I said before, they only had 5 days to make their project, so they had to work quick. Tonight, the teams are going to show you what they've been working on this past week, and then the judges will review them next week. The judges will be evaluating the code, the data analysis, modeling, and I'll be judging the presentation. Results for the winners are going to be posted on the TripleTen Instagram as well as on our school Discord. Okay, now it is time for the fun part where we get to see all the amazing things they create. I'm very excited. We've got 3 teams tonight. So our first team that is going to present for us is Mary Codemus. Mary Codemus has the students Svetlana Kovakina, Anthony Vasquez, and Kelly Shreve.
Hello. I'm
Hello.
sorry, my camera is not working for some reason today.
That's
I have
okay.
I have the second camera, but it's not really cool camera. It's in my laptop.
That's okay.
Uh,
Welcome all the same. Are you
yeah,
able to share your screen?
I'm trying right now.
Let me just double check to make sure you can.
Yeah, I think I can do it. Yeah, can you
Yes, I can
see
see
the
it.
slide? I'm sorry. 1 second.
Yes.
Last preparations. Yeah, good. So are you
Lana,
ready?
please take it away.
Yeah. Okay. I'm sorry. Uh, okay. Uh, okay. Shall I start?
Yes, please.
Um, hey everyone. Merry Codmas is here to save Christmas. So we are introducing Merry Mailers, our new tool that tunes Santa's delivery route to make it super efficient. We spotted a problem. Some people did not get their presents in time. Let me. I'm sorry, 1 second. a family. Mm. Okay, sorry. Um, where did I start? Oh, okay. We spotted the problem. Some people did not get their presents in time. Because, well, it turns out Santa was kind of picking countries almost at random. To fix this, we defined our priorities. Santa should visit all locations in 24 hours, whenever countries he has to visit. And our solution, our dashboard should be intuitive, should has intuitive navigation and responsive design. So let's start with data, because that's the most important part. So Kelly,
Okay, you want me to take it over?
Yeah.
Okay. Okay, hi everyone. I'm Kelly. I'm the data scientist on the team. I think you'll have to advance the slides for me though, if that's okay.
Okay, maybe you can. Okay.
Okay. So as the data scientist, I was responsible for optimizing Santa's route, making sure he can make it everywhere in one night. The first thing that I had to do was to collect data that I could actually work on. And so I found a data set of 245 country locations, their latitude and their longitude, open source on Kaggle. You can see just a little snippet of that data set down at the bottom. So I had country, latitude, longitude, and then name. I checked this data to make sure it was in good condition. There wasn't anything missing from the data set, and all of the latitude and longitudes looked correct. And so then when I went ahead and picked 9 countries that would represent world travel for Santa. So I did 1 country from each continent, which would be 7, plus 2 additional, Greenland and Afghanistan, to represent the whole world. Can we do the next one? And then I went on to fit a random model, which represents what Santa was doing before, just choosing countries randomly. I used the haversine distance to calculate how far he would go if he did random selection. Haversine distance, it's like as the bird flies, but takes into consideration the curvature of the earth. So if you're an airplane or in a sleigh, haversine distance is the correct one to use to tell you how far you've gone. Under this random model, Santa was traveling a whole 55,000 miles, and it was taking him 36 hours to get everywhere he needed to go, which is no good. He wasn't making it on time to visit all of his people. So then I went ahead and optimized the model. Can we do the next slide? Oh, yeah, there we go. The way I did this was in Python. I used the Concord library. This library is set up to do just this. It optimizes the distance between a whole bunch of points. And so you can feed it a distance matrix, in this case, haversine distance, and it'll tell you, okay, this is the shortest route between all of the countries. This Concord library is a good way to do because it's a very computationally efficient. It only took about 0.03 seconds to find this solution. And what it told us was that the optimal start city was in Afghanistan, and then Santa should go to Russia, Australia, Antarctica, Bolivia, United States, Greenland, France, and then finish at the Central African Republic. With this optimized model, he saved about 25,000 miles. So he was able to do it in 30,000 miles instead, and he made it just under 24 hours. So he was able to make it to everybody in time. When I had this optimal solution, I downloaded it into JSON format because that's what the software engineers are able to use. So I put it in JSON and sent it over to my software engineering team, and they integrated it into the website. So I think they're going to share that with you now.
Okay, thank you. Thank you very much to our data science, because she did a great job collecting all data to optimize Santa's route. And now I'm going to share the solution, the final solution. So I stop this presentation so I can show our website. Okay, here our solution. As you can see, it's powered by Santa's magic. So the solution has really intuitive and easy to understand layout, some Christmas cheer and Christmas decorations. Here you can see a map that was created with leaflet library and custom marks with happy Santa's faces. So you can go close and see all countries that Santa visit. If you go down, you can see our previous data and our happy solution with a happy Santa. And of course, you can, if you have a wish, you can send a letter to Santa. So we implemented form validation. As you can see. And when your form is completed, you can send a letter and Santa will get it. Also, if you want some extra Christmas cheer, you can listen to Special Rodolph's podcast, his road music, and get to know Santa's workshop a little bit better. And of course, we implemented responsive design. So if you use a phone or a tablet, the design is optimized for every screen solution. And that's all. Thank you very much.
All right, that was really great. Thank you so much, guys. Again, that was Mary Kodmas, and that team is Svetlana Kokina, Anthony Vasquez, and Kelly Shreve. And Kelly, I wanted to ask you a question being the data science person on the team.
Yeah,
So
please.
this is the first time that we've done a code jam where we have data science students and
Yeah,
developer students. So I'm going to put you on the hot seat and ask
let's do it.
you, how was the code jam experience from a data science perspective?
I thought it was really fun. You know, it was fun to take a problem. I had no idea how I was going to solve it at first, actually. So it was a completely new problem to me. So it was fun to take something that I had no idea how to do, and learn about it and actually come up with a great solution in just a few days. I think the hardest part was taking the data science and combining it with the software engineering, because I've never had to take data science and pass it over to software engineers. So there was really a lot to learn there. And I thought it was a really good partnership.
Awesome. That's really great to hear.
Mhm.
In terms of the time frame, you guys had 4.5 to 5 days on this one. That's a long time for a
Yeah.
code jam, at least at TripleTen.
Yeah.
Did you feel like the time frame was enough, but still, with the intention of keeping the pressure on, right? So you guys would jam it all out.
Yeah, well, I think even though it was 5 days, because there was this data science part that really had to be done before the software engineers could finish their job, I had to have mine done in 3 to 4 days so that I could send it over to them. And then they did the website really quickly, turned it around with that map in just like 36 hours. And so even though we had more time because there was this part that got passed to that part, it was still really short.
So really great example of like real world dependencies on
Mhm.
tickets and projects, right? In between
Yes,
two different departments.
absolutely.
Awesome. Thank you so much.
Thank you.
I very much appreciate you being our very first data science person to answer some questions.
Yeah, thanks for inviting me in.
You're so welcome. All right, we are going to go ahead and we are going to call up Santa's coders next. Santa's coders team consists of Marco Fernstadt, Veronica Steele, and Andrew Kwan.
Hey y'all, can you hear me?
Yes.
Great. Yep. So I'm Andrew Kwan. I work with Marco Fernstein and Veronica Steele as Santa's coders. So you already framed the problem as far as what was the task here. And the way our team interpreted it for our project was to design a delivery route application using a front-end client hosted on an AWS EC2 server, where instead of calculating not just the shortest path for a delivery system, we interpreted it as more of the traditional traveling salesman program or problem. solving the shortest Hamiltonian cycle, which is actually a little bit more difficult problem because not only can you only visit each destination only once, you have to return back to the source destination. So what our application allows users to do is choose a start location and up to however many destination cities you want, just to kind of see the degradation in terms of runtime calculations and execution that you see as you increase the number of destinations. Before we go any further, I will say that we're having a little bit of technical difficulties right now with the actual live service, but we have a backup and a backup to the backup plan to show you at least something that we have going on.
I love it. Super prepared.
So I'll talk about the data side or the data science, kind of the internals first. So what's nice about our application, it doesn't use any external packages or I guess modules. It's all just the standard library stuff, except for the grid or the map plotting and distance calculations, just so we didn't have to do those manually. But just like the first demo, the distance calculations are done in Great Circle routes, so it takes into account the curvature of the Earth. But for our data set, we use the 2020 U.S. Census report for U.S. cities. The original data set included, it's about 20,000 U.S. cities, their city names, states, counties, and their population. But to facilitate a user's choice and destinations, we want to pare that down a bit. So we only chose the most popular cities. So our final data set is only cities in the United States with the populations over 400,000. And what that basically yields is 48 options for the users to calculate their routes. As far as the algorithm and the approach to calculate the shortest Hamiltonian cycle, essentially a cycle that doesn't hit any other destinations and returns back to the source node, we wanted to show kind of progressive iterations of what different algorithms does and the improvements made upon the previous iterations. So it initially starts with a random route where, intuitively, if you try to choose something at random, it's probably not going to be very optimized or efficient. And then we went from a random route to a greedy route where you start at a destination, you basically choose the next closest city and then return back to your source city. And you can see sometimes that works. Sometimes it will actually get it correctly as far as the exact route. But more often than not, it also will be somewhat inefficient, but definitely more efficient than random. But for the kind of the optimized approach that we chose and what we wanted to compare it to was the exact route, which will always calculate the exact route for the Hamiltonian cycle, which currently in the problem is you get a guaranteed solution is still a brute force solution. There's not a single algorithm out there that will actually calculate a Hamiltonian cycle shortest path correctly without it, which is essentially a runtime or a runtime complexity of factorial. And then the optimized route or heuristic approximation approach that we chose, which is called K optimal tours. In this case, we did 2 opt swapping for that, which essentially takes a route, any input route, so a starting route, and then it will iteratively try to switch 2 edges until it cannot improve the cost function, essentially. So it keeps decreasing the distance until it can't decrease the distance anymore. Functionally, what this does is if you think about a map and your route, and there's a bunch of, you take a yarn and you go from each city. The more tangled it is, the more inefficient it is. And so what this optimization does is takes the yarn and tries to untangle it and make sure there's or minimize or remove any kind of crossovers. And what we found in kind of the conclusions portion of it is it will more often than not get the exact route. In fact, it gets it more than 65% of the time, but it's never wrong than less than 1% in terms of distance error. So pretty optimal, and it runs 3 orders of magnitudes faster than the exact approach. A lot of talking, not a lot of showing here, but hopefully the demo that we have can kind of illustrate what we're trying to find here. So with that said, Marco and Veronica, they're the developers that worked on this project. Marco worked on the back end that took the information from the front end client and fed the information to the data or the server backend. And Veronica worked on the client interface there. So
yeah, and I believe Veronica's pulling it up right now.
Right on.
But it was a fun project. We had a lot of fun designing this and building it out. It was very challenging.
Marco, in the meantime, do you want me to just pull up the local instance of Streamlit?
Yeah, go ahead and do that.
Okay, so we'll see if we can get the live service or the local version of the live servers up and running. But what I have as a kind of a backup is it's just going to be the route or illustration or demonstration of the route calculations using a local version of Streamlit. All right. Is this showing up for everybody?
Yes.
Okay. So I don't have it implemented where you can see all the 48 cities, but essentially this is just a very rudimentary design, and then this is going to output a plot of each of the routes. Right now, rather than choosing which kind of route calculation you want, it's going to show all of them and compare all of them. So from here, you can choose your start city, any city, really in the 48,
Tulsa.
in the 48,
Yeah.
Tulsa. All right, let's go for Tulsa. Tulsa, where is Tulsa? There it is. All right. And then from the destinations, it doesn't limit you, but again, because it is also comparing it to the exact route, anything greater than 10, it's really going to hinder its performance since it is going to do the brute force method to give you the exact route as well.
Or maybe you'd pick Houston then. That's pretty close.
All right. So, we can do Houston, but again, we can choose up to, up to 9, and it's going to run pretty efficiently. And by efficiently, I mean, it's still going to be less than about a second for each.
Holy cow.
So we can go New
Yeah,
York.
I was gonna say pick those top ones. LA.
Las Vegas, San Antonio. I don't know. Anywhere else? Anyone else? Any destinations you want to go to?
Why don't we do Phoenix?
Phoenix. Yeah, what we're trying to do
Nice
is create
dry
more
heat, I hear.
any kind of like entanglements, and that's great. So right now we have a start city, Tulsa, and then we have what's looks 7 destination cities. So 8 points on a route exactly. All right.
Whoa.
And so you can't really see the titles, but I can go through each of these. So the yellow route is the random route. And as you can see, as you have more paths cross over each other, the more inefficient it becomes. Next over, we have the greedy route. So starting at our start city of Tulsa, it's just going to choose the next closest city and go from there. And even now, it's very close to the optimal solution, but it still has, this path right here between Omaha, Tulsa, and New York. That if they just chose a different route, it would have been the actual shortest path. But at the bottom, you can see here is the exact route, which is intuitively makes sense because you're never crossing any routes and it's the shortest path. But what's nice is our heuristic route did approximate it and get it correctly. One thing to note, where just how the code is written, the route could go starting from Tulsa to New York. As you can see, ours doesn't, and it actually goes the other way, but it's still going to be close. And I think I just misspoke. It's not the exact same route, but it's going to be close, and you can see that it does essentially the same thing, which is not cross over any paths, if that makes sense. But again, this is technically
the same back end piecework that you guys did for the modeling for your project.
Yep. So essentially for the integration with the back end, I basically put the route calculations into a independent Python module that they can import and then just call the function calls from there.
Fantastic. And Marco, you were on the dev side, correct?
Yeah, Veronica, do you want to pull up the UI? She took care of the front end.
Oh,
sure.
wonderful. I am very interested to hear because it's the first time that we've asked the dev student to also use Python in that kind of way, integrating it with Node.js. And so I'm curious to hear how that went for you guys.
We definitely ran into some challenges when it came to formatting and everything, but I'll let Veronica here speak about the UI.
Absolutely.
Okay, so just working within the time frame, we went ahead and went with more of like a post office kind of theme, hence the blue. We went for a drop down bar here. You can select your current city, your starting destination, based off of all those awesome options that Andrew showcased you just a second ago. You can select all of the same cities the same list of options within your destination cities. You can select up to 6 of them, and then you also have a drop down as well that gives you the choice of which of those algorithms you want to use. And then also, just for fun, we included an iframe so you could zoom out a little bit. For example, if you were wanting to go to New York, you could kind of navigate that on the map. And then once you go ahead, just because this is a front end, it's the technical difficulties, I can't quite pull it up right now. But as you select your cities, and then once you go ahead and run your algorithm, down here, it'll pop up not only your route, but also how long it's going to take you and the total distance that you're covering. In the future, if we had an opportunity to improve it some more, we would love to add actually like location markers on the map itself using like a Mapbox API, and maybe a little bit better data display. But this is what we've got for now.
Yeah, and then for the backend, we obviously configured using Node and Express. I worked on the entire backend from the security with Helmet and Course, which I had to learn about while I was building it out, to managing the routes and the controllers that took care of the data. Working with the Python script was very challenging. Me and Andrew actually were going back and forth a lot about how to properly format the data that we were going to be feeding into the Python script. Eventually, we got that to start working again, and we have everything finished. We had some technical difficulties, and I'm not on my computer, so Veronica pulled it up and doesn't have Python. But it is completed. It's not deployed, but it is completed, and yeah, that's about it.
Sure thing. I can understand. And I guess this is a great question for both teams. And just asking in terms of the support that you were getting from our tutors. So I know that our tutor, Devin, he wrote up a README of sorts for how to move the data from Python and, well, integrate it rather with Node.js. And was that supportive enough? Did you feel like that was like you would have had more, you wanted less?
I think it went fairly well for the most part. Devin, actually, him and I were going back and forth. He hopped on a Zoom and helped me out with a few things that I needed some assistance on when it came to running the Python. The biggest trouble we had was actually with the deployment. A lot of the steps are in Sprint 15, and since I'm not there yet, I didn't have access to them.
That makes sense. That makes sense. Well, that's definitely good feedback for us as we're looking ahead to setting up, one, our teams, but then two, making sure that we have some README supports, right?
Yeah,
we do
and we had a
recognize
lot of
that the
fun
teams
doing
are
this.
everywhere.
Yeah, we had a lot of fun doing it overall. I know Veronica, she learned a lot. She got to push her limits a lot.
That's awesome. Well, again, this was Santa's Coders, and that team is Marco Fernstedt, Veronica Steele, and Andrew Kwan. Our last team doesn't seem to be in attendance this evening, so we're going to put them on the naughty list. But I'm sure something has come up, and that's okay. We do have their work, and I did want to go ahead and mention them while and their team. Their team are the Coding Elves, and clearly because it's so close to the holiday, they must be busy doing their elf duties somewhere. That team consists of Dylan Arnold, Ruben Pinkashov, and then Leah DeYoung. So, with that, those are our teams. And that concludes our presentation for the evening. So what's going to happen now is we're going to take the presentations, we're going to take the code GitHub repos as well as either the local deployments or the actual deployments, and we're going to go through and give them to our judges, and our judges are going to grade both the data models and they're going to grade the front end, back end development. You guys did a really great job. Everybody on this call, you guys should feel really proud of yourself. This is the first time we've ever done anything like this where we put devs and data science programs together. And so, for me personally, I was a little nervous, but you guys really knocked it out of the park. The fact that you guys have things to demonstrate and that it doesn't always go smoothly, but you're able to get even one minimum viable product out, you guys really need to know how amazing that is. So feel very proud of yourselves. I know I am feeling very proud. From all of us here at TripleTen, this concludes our Jingle Bell Jams presentation. Thank you so much for watching. Pay attention to our Discord and our Instagram at TripleTen Tech. Friday, we will have at 6 p.m., we will have the results posted there. I want to say a special thanks to everyone who helped organize these code jams. Zach, Dimitri, Devin, Andre, Olivia, and of course my cat Sharkbait. Couldn't do this without him. Thank you again for all of the participants from both the development program as well as the data program. This is just, I continue to be impressed with the things you guys can turn out in such a short period of time. But I really appreciate your courage and your enthusiasm. My name is Tiffany Hall, and you can find me at Tiffany Codes on Instagram. You can find my business at RilexCustomWorks.com, and you can probably find my cat at his food bowl. Thank you guys so much for watching. Have a great evening.
Bye, everyone.
Bye. Thanks again, Tiffany.
Bye, everyone.